But yeah, welcome everyone. Thanks for coming that early.
Yes. My name is Mila. I will be your host for today. Today, Igor will talk about data science projects in general, about how to do it from the start till the end. So some practical data science, which is done in everyday life, all in one place. So
Good.
I will.
Yeah, then I
Igor
will.
could introduce himself.
Yeah, I will start my presentation then, and just tell me when should I go.
Okay. Okay. I think we can see our presentation now.
Perfect. Yeah. Then hello once again. I'm Igor. We are at the meetup of X Technology. Yeah, you can see the logo on the right. Today I am here as partly a member of X Technology and also an employee of Crayon. That is the company where I work on. And I work there as a data scientist, as you could have guessed. And today I'm going to talk about one of the projects which we worked on together with some of my colleagues from Crayon and with our partners, which names I won't unfortunately name. But there were quite some very nice people. So this project is in the domain of finance, so particularly banking or debt collection. And today I want to share with you a lot of details from it. So we will start from initiation of the project. So some discussions regarding business problems that were there. And I will slightly move into technical aspects, look at different at data, at some of the modeling parts, and then slightly jump into infrastructure parts and finalize it with a recap. So actually, I was also already talking about the agenda. So let's start with some business overview. As I said, this is the area of finance and particularly debt collection. So I would just love to introduce the counterparties to make it easier a bit for you to follow in the future. So first of all, there are some organization, for example, a bank, which can issue the credit or loan, for example, a mortgage or a car loan. And then there is a person, currently a debtor, or the one who gets the loan, and they assign or arrange the payment plan between of them. So usually the person is obligated to pay some amount of sum every month or every quarter. And if everything goes well between them, so every month there is a payment, then the bank is happy and the customer is happy. And after some time, the credit is fully repaid and the contract is over. But in some cases, something bad might happen, and the customer is not able to pay for 1 month and maybe for 2 months in a row. And after a while, the bank begins to be really disappointed. So they don't like that the customer is not paying for quite some time in a row. And at first, they will try to ask the customer what's happening, why not paying, when you will gonna pay. But if it's like really happening for like consequent months, then that's not really their business, and they don't want to handle that kind of customers. So that's why they just sell that kind of loans to specific organizations, which are collection agencies. So that's how our main hero of this today's story comes into the stage. So collection agency picks up these portfolios of the customers who are not paying for quite some time and tries to deal with them on their side. So basically, let's speak a bit about the debt itself. So as collection agency buys the portfolio of debts, it consists of a lot of single ones. And let's look at the life cycle of a single debt. So first of all, when the debt is not yet past due, there are regular payments every month or quarter, and everything's going well. If this past due is happening, so meaning that the customer is not able to pay, then the bank starts to worry if this event happens for a couple of months in a row. Then the bank sells this credit to or debt to a collection agency. So this is the acquisition by collection agency. The collection agency also works in a similar way as a bank. So we also settle a payment plan together with the customer, or maybe sometimes without the customer. And also there are some scheduled interactions. So collection agency is poking from time to time the customer, asking how's it going? Are you gonna pay this month, or is everything good? Do you think you're gonna pay? So on. And then if on this stage everything goes well, then after some time there is a full repayment, meaning that the debtor was able to fully repay their debt. Or if it's not the case, then the next stage of this life cycle comes into place, and that's a legal stage. So meaning that the collection agency is going to the court because they cannot do anything with this customer. Yeah, so let's here we try to Here we try to specify the specific the challenges, particular challenges which are in front of the collection agency, and we group them to three different pillars. So the first one is everything which is connected to the payment plan. So first of all, it's sometimes it might be really hard to reach the debtor because the collection agency doesn't always have the phone number or the address, or sometimes it's the phone number of some random person. So even on this stage, it might be difficult for collection agency to do something. Then the second thing is the discounts. So of course, there are smart people in collection agencies, and they understand that if the customer hadn't paid to the bank before, then probably they have some issues with money, and it makes sense to ask them to repay not the full sum of the debt or the loan, but the diminished one with the discount. But here is the question. So you don't want the customer to pay too few sum, and also you want the customer to pay something. So there is some optimum in offering this discount. And of course, there are some costs which are connected to these processes. So it costs money to call the person. It costs money to prepare some discount for a specific contract. So this we will call amicable costs. So amicable meaning that we are not going to court. We are pretty amicable with the customer so far. Then the next pillar is legal aspects. So that is, of course, when we already might have gone to the court. Yeah, so there is this contact-free period. We implemented this project together with our customer, and this customer operates in different countries over Europe. And in these countries, the legislation acts are slightly different. But in some of them, there is this contact-free period, meaning that when the debt was just acquired by the collection agency has no rights to contact the customer for the first months or maybe 2 months, depending on the country. So that introduces a couple of problems. So collection agency should deal with the debts on their own during these months. Then the next thing is bankruptcy or restructuring. So again, in some countries, private individuals can apply for individual bankruptcy or private bankruptcy. I'm not sure how it's called. So meaning that if this bankruptcy is approved by the state, then all the debts will be written off or wiped away. And that's, of course, a very bad thing for a collection agency. They don't want to lose their debtors without them repaying the debts. So, yeah. And the legal costs, of course, if the collection agency decides to go to the court, then there are a lot of costs connected to this. And the next pillar is technical things. So as there are many multiple customers, we need a lot of particular strategies or tailored strategies for them. But also it doesn't make sense to create a strategy per customer. So probably it makes sense to create some groups. Then the data quality. So of course, data quality is an issue in every data-related project. Here we also stumble upon a couple of things. So in different entities of our partner. The data is being processed in different systems. So first of all, it's a lot of different tools, and then sometimes you have to deal with raw CSV files, and sometimes you don't have all the history. So all the usual data quality problems. And yeah, of course, it's like a lot of manual labor. So first of all, the agents on the collection agency side, they have to call all the debtors. It's manual labor. Then if we consider all the customers and try to come up with some strategies for them, it's also a lot of manual labor. So there are people who call strategists who come up with different ways of how to deal with the customers best to get more repayments. And these areas are really prone to be these are the areas of the main challenges where we see a lot of advantages or possibilities, let's say, for data science approach. Yeah, that was a small overview, just trying to get you on the same stage. And now we will talk a bit more about technical things, and so about data science applications. And these are the use cases of data science that we came up with when we first looked at the business challenges. So first of all, grouping debtors by behavior, that's what I already mentioned. So you have a lot of different debtors and they have different behavior in the past, and you don't want to process them one by one, but you would like to create groups and then handle these groups as a whole. So meaning like you will really decrease the amount of work for collection agents. Then the second thing is forecasting the cash flow. So of course, every financial department of almost every company wants to know what's going to happen in the next quarter or next year. So they would like to plan their expenditures and income, of course. And see here the idea is to predict the forecast the cash flow. So how much money will be collected from the debtors in the next periods to plan accordingly. The third thing is better interactions. So the usual interactions between the customer collection agency and the debtors is just calling, so the phone calls, and there are a limited amount of agents and a lot of different customers. So meaning that you have to somehow prioritize which debtors to call first and which to call last and which you shouldn't call at all. And also, you basically have to optimize the time spent of your agents for this work. So let's say if you have 10 agents and you have to call 100,000 people, you have to somehow optimize that the agents are not waiting on the line for the customers to pick it up. So there are quite some smart systems which allow the minimum waiting time on the line. Another thing, optimization of discounts. So basically what I mentioned before, if you want to offer a discount to the customer, to the debtor, we would like this discount to be as low as possible so that it will make an impact, so that the customer will accept it and repay instead of non-repaying. But we don't want it to be too high because otherwise the collection agency won't get any profit from this deal. And this bankruptcy prevention, so of course it's nice for collection agency. It will be nice to know when the customers are going to apply for bankruptcy and to prevent it. So maybe like a couple months in advance, offering a nice discount will help, and the customer will change their minds. Instead of going to bankruptcy, they will accept the 40% discount, and that will be a win for the collection agency. So now we could try to shift a bit or reformulate these tasks into more technical things, into machine learning tasks. And here I stopped with 3 main ones, which we spent some time during the last months. So the first one is predicting the propensity to pay. So what is it? That's basically predicting, that's a classification model, and it predicts whether the debtor will pay any sum in the next months. So whether the debtor is willing to pay. So propensity is kind of willingness to pay. And the next, it could be like the next 1 month or the next half a year. So it depends on the context. The second one is estimating payment amounts. It's obviously a regression model. So here we are predicting the exact amount of the payment that the customer will make in the next period. And the third one is also a classification model. So we're classifying whether the customer will apply for the restructuring or not in the next n months. So let's say half a year. Yeah. So now, I would like you to understand a bit better what data we have. And again, I divided everything into 3 entities. So first entity type is debt or debtors, and they have the usual data that they might have. So for example, if we're talking about the debt, it's of course the initial amount of the debt, the interest rate, the product type, how many days it was past due, and these kind of things. And if we're talking about the debtor, who is a real person, then of course we might have the age, also might have the gender, although this information is sometimes quite hard to obtain. So not all the countries have it. Sometimes for example, region of residence might be there, and very, very rarely some more private information sometimes, for example, if the person is married or not. But as I said, this information is quite sensitive and not always there.
Igor, we have a question.
Sure.
Coming from Dima.
I will be happy to discuss it.
Yeah. Yes. So in the previous slide, if you could go back, the estimation of payments amount, you mentioned it's obviously a regression model. Unfortunately, it's not so obvious to me. Why is it a regression model? Could you elaborate a bit more on that, please?
Yeah, sure. So basically, briefly speaking, there are 2 types of machine learning tasks. One is classification. So that's where we try to predict whether some fact will happen in the future or not. So basically, we predict either yes or no. And that is a classification, so meaning the first and the third model. So we predict whether something will happen, the propensity to pay or the restructuring. And the second type of machine learning task is regression. So that's basically when we want to predict the exact amount of something. So for example, when we want to predict the price of the house, given the features of the house, or when we want to predict the amount of the payment, given some features. So just these 2 differences, whether we want to predict the yes, no of something, whether it might happen, or we want to predict the exact value of something.
Yeah, perfect. Thank you.
Yeah, you're welcome. Great. So so second type of entities is what I called interactions. So that's everything which happens between the collection agency and the debtors. And for us, it's different types of calls. It could be outgoing calls, incoming calls, so also emails sent, and even paper letters sent. I'm not sure about coming to the debtor physically. I don't know about it. Probably not. And also all these calls and emails, they have some content, and this interaction might have some result. So whether the customer might have said something or didn't pick up the phone, that's also a result of the interaction. And the third pillar is the target actions. So that's basically usually what we want to predict. So for example, the application for restructuring, or the payment. So it could be the fact of the payment. So we will use it for classification model, or it could be the payment itself, and we will use it for regression model. Yeah, here I would like to focus more a bit on the classification models, because first of all, I like them a bit more than regression, and to me they are a bit more straightforward and easy to handle. And what are the usual friends of classification models? So of course, of any models actually. So of course, we have to define the metric or the metrics, which we want to track and improve. And my approach is usually, when I deal with classification models, I would like to first tune the model in a way that it's generally speaking, okayish. So meaning that I would like to pick up some metric which is one number, for example, area under curve. And after I am sure that this area under curve is some kind of somehow acceptable, so I would like to have some minimal threshold in my mind, depending on the domain. So after I achieve this metric, I will already jump into precision and recall. So precision and recall are dependent on the threshold which we pick of the model. And so meaning that I usually don't like to deal with the threshold right away before even knowing that my model is good enough. But when I'm sure, yeah, of course, this precision and recall should be taken into consideration. And also that's the moment when we have to go to business stakeholders and ask them what is worse for the business. Should we try to decrease the false negatives or false positives? Could we somehow convert the false positives or negatives into expenses of the company? Or so yeah, basically as technical people might have not too much of a domain knowledge, it's very useful to talk with business people on this point. They might help a lot in defining the thresholds. Yeah, also there is this metric lift at n. I won't stop with it for quite some time. It might be useful for some tasks. But then the models themselves. So in this project, we didn't.
Igor,
yeah,
sorry, please, can I interrupt you?
Of course.
Why do you choose area under the curve first as a metric that you will orient with?
Yeah, so as I said, I would like to have some general metric which is not dependent on a threshold to evaluate how my classification model is behaving in general. And I usually pick up the area under curve because, yeah, I just like it. I know that there is, so I'm talking about ROC area under curve. There is also precision recall area under curve, but I'm not a fan of it because there are no predefined range of this metric. And for this metric, we definitely know that it changes from 50% to 100%. And I could basically evaluate how good our model is when I look at this metric.
Okay, something like universal orientation. And what is lifted then?
Yeah, so it's so this metric is often used in some tasks where you need to promote something. So, for example, if you have 100,000 customers, but you want to send some specific email to only a small chunk of them, and you want to pick like a top 1,000 of the customers which will react on your message in the best way. So then you just build the model which ranks the customers, and you see how your model is good at ranking of the top 1,000 or top N customers. So this metric shows you how good your model is only on the top N customers, not on the whole data set or population of them, but on the top N. So it might be useful when you don't care about the whole population, when you just want to pick the top N candidates.
Interesting. Great. Thank you.
Yeah. Yeah, thanks for the questions. I feel that there are people. Good. Yeah, so yeah, then the models which we used. So we didn't go for anything fancy for deep learning or that kind of stuff. We started from the simple baselines, which are linear models. So meaning logistic regression for classification and linear regression for simple regression. Then, of course, we switched to trees and random forest, and we tried a bit of boosting like XGBoost or CatBoost. But I could say that in most of the cases, for now, we just stayed at random forest because it's a nice mix of not high complexity and good enough results. So let's say like this. And the next aspect, which is really important, is the dataset split. So of course, we do cross-validation to be sure that we do not overfit as much as we could and to find the best parameters of the models. But also there are these two things. So first one, representative data. So we have, for a lot of countries, we have quite a lot of customers, and also we have quite some history for these customers. And we know that sometimes some really specific things might happen, for example, COVID in 2020, and we would like to take into account all these specific events that might happen. So usually you train your model on the latest data that you have, but in this case, we might want to preserve some older data just to incorporate in the model a lot of different ways of historical behavior. So let's say today is October 2021. And if we train the model, we probably would like to get the data from September 2021. But also, if we want the model to be able to handle specific use cases like COVID, we might introduce a bit of the data from 2020 or some, or like maybe April, when the results of the COVID kind of appeared in the data. And it might be useful, again, for the model. And yeah, the thing about metric overestimation. So I have a specific slide for it. So that is how we split our data into train and test. So for example, here is a small example. We see that there are only two customers, debtors, so debtor A, debtor Z, and we have the data for them for September and for October. And one of the ways how to split the data set on the train and tests could be like this. So we get both of the debtors from for September and put them to train data set, and the same debtors for October we put to the test data set. But if we look at the values of the features, so here I just put three features. It's initial debt, current debt, and the amount paid by the customers during 1 month before. So we see that for the customer A, it's red on this picture. The features are really similar in September and October. So the initial debt is, of course, the same. The current debt is slightly different, but not that different. It differs only by 10. And the paid amount is also the same. So because the customer is usually paying 10 every month. So that means that the row in the train and the row in the test are really similar. And basically the same goes about the customer Z. And it will be quite easy for the model to guess the right answers on the test, I would say. So that will make our metric a bit too optimistic. So if we will construct our data set in this way and get the metric which is over the top, then we should not be too happy, but we should think about making the life of the model a bit harder. And that's how I could make it a bit harder. So for example, in the train, I could leave only the first customer, so the customer A, and on the test, I won't put the same customer. I would leave only the customer Z. So in this way, the model won't be able to overfit on the same values, on the same features, and it will have to somehow guess the real general interconnections between features and targets. So in this case, we will achieve a bit lower metric, moderate, but it will be more fair, let's say. So yeah, I always prefer not to get the highest metric, but to make the life of the model as tough as I could. Perfect. Yeah, so that's quite a while that I'm talking and not jumping into any real hands-on. So here is a piece of code that we used for this feature engineering. This is a feature engineering devoted to introducing some nonlinearity. So you see that initial features have something like initial principal amount, initial interest amount, or current principal. And the idea was to introduce some ratios between them. And that will probably help the model look at the problem from different angle. So here we create something like interest to principal or principal left, dividing a principal current by principal initial. And also we do the same with some time spans, so to get some ratios between time intervals. So feature engineering around the interactions. Yeah.
I have a question. How you came up with all those ratios? Is that something from domain knowledge, or that is something that you usually do? You often use ratios?
Yeah, that's a great question. So it depends. So in this particular case, it was a mix of both. So of course, we first talked with people having a domain knowledge and asked them what is really useful, or what do you personally use when you do this task manually. And then we understood that these ratios might be really important. And then it was a bit of a creative process. So think about the ratios that might help. And yeah, so next time I might have the similar type of the task, I would go for ratios right away, even without the domain knowledge. So it could be kind of a mix. It could be from both directions.
And how do you know which ratio is really helpful and which one is really useful for the model?
On this stage, I would say there's no way to know. So on this stage of feature engineering, I would just add as much as I could think of. And on the later stages, when I run the model and evaluate the model, I would see which features are useful, which are not. Basically, on this stage, yeah, I prefer to think of as maximum of as I could think of, put everything I could, and then let the next stages decide whether it's sensible or not.
Okay, thank you.
Yeah. Sorry?
Thank you for your answer.
Yeah, thanks, Mila. Yeah, actually, I really like the questions, so please do ask me. And yeah, so how we handle these interactions. So as I said, all these phone calls or letters sent or emails sent, they usually have some results or outcomes. So usually it's in the way of comments, like in a text format. But thank God, sometimes there is some column which has only a limited amount of the different distinct values. And here we try to map these values to some smaller amount of results. So you see that we classify the calls on outgoing and incoming, and we decided that we will deal with some negative and neutral and positive output. So meaning that if the customer said that they're gonna pay in the next month, so they for sure will pay, we said that it's a positive result. If they said something like I don't know, they don't know, they want to reschedule, they don't have that money right now, that probably will be neutral. But if they do something negative like hang up or said that they, I don't know, it's a wrong number or something else, then it's definitely negative, and we should consider it as a negative in our data set. That's basically how we put into features all this massive amount of text information. And a small tiny thing about aggregations. Yeah, of course, in the initial and the raw data, we have something like this. So there is a row about the debtor and the date and the amount of payment that they performed. But we cannot put it directly to our features data set, and we process it in this way. So we say that every debtor has some historical behavior. And for example, it could be the average of payments for 1 month or the amount of payments in 1 month. And we just calculate all these aggregations for all the customers. And this is already, so this data set is already something that you can use in the final model. Great. So a nice picture, and you most definitely don't see anything on it, any text, but that's not the goal. So I just wanted you to look at the patterns here. And this picture is the mutual correlations of all the columns. So correlations of every column with every column. And we see that there are some patterns. So for example, a huge square in the middle, and also a lot of tinier squares in this square. And it means that there are quite some correlated parameters. So for example, I would like you to believe me that this square represents the payments. And the features are the payments in 1 month, the payment in 3 months, and 6 months. And we see that they are highly correlated, meaning that probably for the final model, we shouldn't include all of them, but we should leave only one. Yeah, and yeah, as you see that there are like quite some features that should be probably eliminated before going to the final model. And the second interesting thing here is, yeah, the very last row, which is our target. And here we see that, or actually, I would like you to believe me, that there are no high correlations between the target and any feature. So the last row doesn't have anything really red and anything really blue. And that means that there are no really strong predictors that we could use and be really happy with the model, but we have to use all of them and hope that the combination of them will work nicely. The highly correlated predictors are the previous payments. So that's this region, and of course, the more payments you had in the past, the more you could expect in the future. So they are correlated positively. And I think the second one is current debt. So this is a bit on the other side. So the bigger the current debt is, the less probable the customer will pay in the future. So that's a negative. And I think that's this tiny red small square. Good, yeah. So a bit of other part of EDA. Here is the graph where we try to represent the data and understand it a bit more. So on the x-axis, we have the collection months, or it's the age of the debt. So when the collection agency acquires a debt, the age is of course 0. Then with the time, the age increases. And here we wanted to see like how the target changes with the age of the debt. So the target is the red line here. It just represents the average target for all the customers having this age. And we see that when the debt is quite young, so during the first year, the average target, so the average willingness of the customers to pay is quite low. And then after a year, it jumps to a bit to higher values. And then again low. So this, of course, something that's a bit hard to interpret with only technical knowledge. So definitely we had to talk with business stakeholders. And actually, this might be devoted to something like at first months, the collection agency would like to handle the debtors in an amicable way. But then if something goes wrong, after some time, they will incorporate the court and they will switch to legal. And that's why after some time, we could see that the court might be more effective. Yeah, also the blue dots here represent the amount of debtors, just to see that the data set is not really uniform, and we might want to handle this in some way. Yeah, if there are any questions.
We have yes, one from Mikhail, I suppose. Could you specify the data dimensions, number of features and instances or rows?
The data dimensions. So let's go back here. So as I said, the data consists of these three things. So for example, you could think of one data row as something like the features of the debt and the debtor, the interactions of this debt and the debtor, and the targets, whether there was a payment or not. So meaning that one row is one debt, and all the features that happened with this row in the past are also in this one row. The dimensions, meaning probably the amount of features. Yeah, I'm not sure if I can disclose it, but I could say that it's not thousands, but also not 5. So something around dozens, couple of dozens. And the amount of the data sets, it again depends on the entity, on the particular entity, but usually it's, I would say hundreds of thousands. But again, it's if we want to somehow tackle particular groups specifically, so meaning that we see that different ages are behaving in a different way, that then we want to split our data set, and the smaller chunks of data set will become smaller. Yeah, I hope that it's helpful.
Mikael says it is. And I wanted to ask, how do you present a graph like this to a customer? So how you translate some particular graph to a customer? This is, let's say, a complex one. You have a line, you have dots, you have few axes. So how do you usually translate it to customers, which are maybe not that much into graphs and axes and lines and dots? Is there a good way to do it?
There should be always a better way. I'm not sure about the best, but the better, of course. Yeah, so that's an awesome question, and that is like one of the main things that you have to think about when you're creating all these graphs. So first of all, yeah, of course, I draw them for myself to understand something, but then if there is something meaningful and I want to share it with different people, I think of how to make it a bit more readable. And this particular graph probably I wouldn't share with, let's say, business people, but I have one on the next page, and I will probably go there right away. So this one, which I really like to share almost everywhere and with business people as well. And I will try to explain it to you, and I will hope that you will understand. If not, then I will fail. So, well, I will go and learn how to do it better. So that is one of the output of the classification model, which predicts this propensity to pay. So whether the customer will make the payment in the nearest future. And again, the x-axis has the age of the debt. So starting from zero, it's the age of the debt in months, starting from 0 and up to like 3 years. And on the y-axis, we have the results of the metric of the model, which was trained on these debtors. So basically, we took the whole data set of the debtors, and then we took only the ones which have the age of 1 month. We trained the model on them and got the metric for them. Then we did the same for the debtors with the age of 2 months. Pick them out, train the model for them, and get the metric for them. And that's basically, we trained quite some models here. So meaning every dot on X, for every age, we trained a separate model. And now I put them into one graph, and just to see how our model is capable of dealing with different ages of debtors. Oh, sorry, not debtors, but debts. And here we see 3 lines. So they represent 3 different targets. So the red is for the target of 1 month, and then blue is 3 months, and green is 6 months. And the first tiny observation, which could be taken away from here, is that it's always easier to predict the shorter time horizon rather than longer. So we see that the target of 1 month is almost always higher than 3 months and 6 months. So that is one takeaway. And another interesting thing is like the shape of this curve. We see that in the very beginning, when we just acquire the debt, we don't have too much information. So we basically don't have the behavior information about this debt. We know only the initial value, how many days was it past due before we acquired it, and maybe the gender if we're lucky enough. And we see that our model is really struggling to find something meaningful. So the area under the curve is around 67% here. And when we go a bit to the future, we see that even on the second month, it jumps a bit, like around maybe 3% up to 70%. And then with the following upcoming months, we see that the metric jumps really higher to around 80%, or maybe something lower, and it stays there for quite some time, meaning that we already have some information about the debtor. We see how they paid or not paid in the first couple of months. We already had contacts with them, so we called them. They either picked up the phone or not, and probably they said that they will pay or will not pay, and all these things. And another big step we see on after a year, and basically here the model is predicting almost perfectly. So the area under the curve is around 95%, which is very cool, but it might be a bit useless because, as I said before, 12 months is quite a lot, and probably the collection agency is already not really interested in these kind of debtors because it's easier to send them to court to start the legal process rather than try to deal with them amicably. Yeah, so I tried to explain it. So hopefully it was clear. If not, I could try once again, or I will go back and cry and learn more.
Okay, thank you. Dima has a question.
Yeah, judging by this graphics, I can see that, for example, on 6 months, there is a drop in propensity to pay. On 12 months as well, and 36 is a bit of on the downside as well. Does it mean that people are not willing to pay after 6, 12, and 36 months? Or is it just a data set was somewhat like this? Or could you maybe, how would you explain that to a customer? It's just interesting.
Yeah, it's, I'm not sure if I have a nice explanation. So yeah, you're really right. There are some drops on 6, 12, and 36, which is quite, or 37, which is quite suspicious, honestly, because it's like half a year, and 3 years. Maybe there is something in the data, you're right. But honestly, yeah, I'm not sure. I'm not ready to answer here.
But generally, this kind of graphs will basically give you some insights on these things, right? So they are designed to get those extremums and see what's happening.
Yeah, for sure, because maybe that business people might have some ideas why it happens. And also, when I was plotting this graph, I didn't know that it will look like this. So I had just an idea. So let's try to do this. And now when I saw this, I personally got some insights, and of course, like some of these insights were quite obvious for business people, but they really helped me to understand the data better. So so I'm kind of showing it here because I found it useful for myself, but of course there are a lot of different ideas how to put the data on the graph, and sometimes they are not really successful, not gaining any insights for us.
Cool, thanks.
Sure. Yes, so also I would like to share a thing which is not like a direct result, but close to it. So feature importance, also from the different model, which is depth restructuring classification model. Just was like something interesting for me, quite a couple of observations. Of course, the most important feature is the total amount of the debt for the customer. And also it's really important how it changed in the last 2 years and 1 year. So all the features about the amount of the debt are on top. But what is interesting, we have this feature marital status on the 5th place, which is a bit surprising for me. And a lot of different discussions about fairness could be started here. So whether it's okay to use this kind of features in these models and different models, or whether it's nicer to be married or not for these models. Yeah, I actually don't know the answer. And one another thing, so here is a feature depth request. And I really wondered why it's not the top one, because basically what this feature is representing, it says whether the customer applied for the restructuring before, sometimes in the history. And to me, if the customer does it once, then probably it makes sense that they will do it the second time. So to me, it will be like a very important feature, but it's not the top one, which is quite interesting. Also, like looking at these kind of graphs, it might be meaningful to look at the lower area and discard the features which don't bring any importance. But of course, there are multiple ways how to look at the importance. This is only one of them. And there is no like silver bullet of eliminating the worst features. Yeah, another piece of results which goes about the regression model, where we try to predict the exact payments that the customer will perform in the future. And yeah, here I have two graphs. On the left, we see individual predictions. So every blue point represents the single debt and single predictions. They are all scaled to 1. And on the left, we see the true values, and so there are quite some outliers. And the distribution is, of course, skewed, not normal, like always in real life. And it introduces a lot of difficulties to the model. So the basic models like logistic regression or random forest regressor, linear regressor or random forest regressor, they have quite some hard time trying to generalize the knowledge. And you see that the outputs of the model are quite dense. So they obviously cannot predict outliers. And there are a lot of metrics how to evaluate the regression model. I put a lot of them here. And I just could say that they are very bad, like really bad. So this model could hardly be used with something meaningful. But the nice thing that our model could really predict the mean of the population really well. So we see that the mean of the true values and the mean of the predicted values are quite close. And that means that we could aggregate all the predictions, and the sum of the predictions will be quite close to the real sum. And this fact might be used for forecasting the cash flow or the monthly collection. So here are individual predictions, and if we sum them up, we will have a point which I put here. So basically, the total amount of the collection during the months, we are able to predict it quite accurately. So here's a graph for 3 years ahead, and we see that almost every month we are able to predict the collection months ahead, quite close to the real data, which is also a nice takeaway. So the model itself might be not working, but if you try to combine the data in a different way, you might also find something useful and use it in a different business problem. Yeah, now I would jump to infrastructure things. If there are some questions about technical side, probably a nice time to discuss it. So I will just drink a bit.
A question from audience. Mikael is asking, can you say a few more words about how you dealt with outliers, left them, dropped them, transformed them?
Yeah, so honestly, here I finally didn't find the right way to deal with outliers, because if I drop them, then of course our model will be able to predict the dataset nicely and our metrics will look much better. But in real life, it might be not really meaningful because outliers are happening in the real life. And if your model is not predicting them, then probably you lose something. I know that there are some types of the models that could handle outliers better. Honestly, I'm not an expert in this. One thing that I might think of is introducing some Bayesian approach when your prediction is, so when you try to kind of simulate the outcomes and you don't have only one outcome, but for example, on the prediction time, you simulate the outcome out of some distribution. And that might probably help. But yeah, as I said, all the things that I've tried didn't really bring any meaningful results here, and I just basically gave up on this regression model. So if anyone has like a nice source of where to look for how to deal with outliers in regression models, I will be really happy to look into it.
And how do you deal with missing data?
Missing data, yeah. So again, if, for example, if we're using linear models, it makes sense to fill it with something meaningful, like, I don't know, mean or median. Or when I'm dealing with tree models, like random forest, I usually just create a really weird value. So, for example, if we're considering the value of, let's say, income of the customer for the last year. So if we have a missing value, then I just put there minus 999, something like this. So completely meaningless value. And then I'm pretty sure that random forest will be capable of saying that this is something specific. So that is not the real value, and it will put it aside. Also, we could create a separate feature, for example, that will say if value is null or not. Another way will be just to drop these columns, or yeah, sometimes columns or sometimes rows from the data set, but I'm not a fan of it. So yeah, I'm usually going with this dumbest idea of imputing it with something meaningless and letting three models decide how to deal with it.
Okay, thank you.
Mm-hmm. Good. Yeah. So just a couple of words about infrastructure. So first of all, this shiny and colorful plot or graph. And thanks a lot to Sebastian Knigge. That's his creation. So he did it. I just stole it from him. And it represents the overall architecture which we used during this whole project. We so as I said, yeah, our customer operates in different countries, and all these countries were kind of a different project, but we tried to generalize the approaches and have more or less similar architectures. And everywhere there is something on-premise. So this like rectangular on the left represents on-premise facilities. And usually it's just a database. So where the customers, the collection agency is storing their data. And also they have some debt collection system, which is a CRM system, the one which is used by collection agents. And then the thing on the right, this is the cloud. So particularly in this project, we used Microsoft Azure. And there is a number one, it's like the connection between them. So this is the piece of software which allows us to get the data from on-premise to cloud and ingest the data back from on-cloud to premise. So that's how all the processes are usually starting. So we retrieve the data from this database and put it to the cloud. Yeah, on the cloud also there are a lot of, not a lot of, like three separate things. So first of all, there is this orchestration tool. So this tool is doing the ingestion itself. So it grabs the data from on-prem and puts it then back to the storage. So here we store the history, and then the storage, the data, the storage could be pushed to this machine learning circle. So here we do everything which connected to machine learning. So we are training the model. There is a training pipeline, and we are inferencing. So we're scoring the new data with already pre-trained model. Yeah, and as I said, so we are using here Azure ML. So the main two tools, orchestration tools that we're using is Azure Machine Learning. So everything is connected to ML, training and scoring. And the higher level orchestration tool is Data Factory. So it's able to trigger the processes in machine learning. Also, it's able to get the data from on-premise, to push it back on-premise, and doing some preprocessing itself. So some of the preprocessing is also happening within the Data Factory. Yeah, here is a lot of different logos. So on the left, I put the logos which we kind of used to some extent. And of course, yeah, that's aforementioned machine learning and Data Factory. Also, we're using databases, which is MS SQL servers, and the usual friends of any data scientist, scikit-learn for modeling, and Jupyter for explorations and EDAs. And another fine, nice library which I just recently found out during this project is Great Expectations. So it allows you to create data quality checks over your data. It's very handy. So if you want to know how many null values or missing values or outliers of some type are there in your data, so it's a very nice and handy tool to use for it. Yeah, on the right, there are other different tools which could have been used for the similar project. For example, yeah, if you want to if you want to use some other paid service, if you're on AWS, you could use Amazon SageMaker, which is an analog of machine learning. So it's capable of it's capable of dealing with notebooks. It has model registries. It has data sets. It could run pipelines of machine learning and so on. If you want to do something a bit more on your own, and if you're a bit more hardcore, you can go directly to Spark, for example, and do all the preprocessing in Spark. But there are like a downside of handling the cluster. If you don't want to handle Spark cluster on your own, you can use Databricks, which is pre-managed service of Spark. And I think it's available on every cloud now, on every major cloud, like Amazon, Google, and Windows, or Microsoft, sorry. Another thing which is capable of doing basically everything you can imagine of is MLflow. There are like a lot of sub-tools in these tools, and I think you can literally do everything about machine learning with this tool. But it's super highly customizable. Yeah, so Airflow is a very nice tool for scheduling different jobs or pipelines. So if you have the pipeline of getting the data from A to B, or running some SQL query every day or every month, the Airflow is a very low weight tool of allowing you to do this. Yeah, and a couple of others. So I just like Google BigQuery. That's why I put it here. Cool. Yeah, so a small recap. Hopefully you're still there and you're not too bored. Just a summary of what we've been talking about today. So first we discussed some business challenges, and then we try to convert them into direct data science tasks. So connect business with data. Then we talked about a bit data structure, feature engineering, some EDA, also mentioned metrics, and slightly looked at model results, and also discussed a bit of tooling. And yeah, some key takeaways that I want you to get from this talk, maybe. First of all, machine learning can help real business, for sure. You just have to talk with people who are deeply in the domain knowledge long enough to get their problems, to understand them, and to know how to convert them. So particularly in our use case, ML might help with clustering users for legal actions, or predicting individual events like debt restructuring or bankruptcy, or streamlining interactions. So as I said, there is this specific tool which tries to order the customers to make the calls more efficient, so that the agent is not waiting for too long on the phone. And there is a huge area of optimization tasks. Quite interesting to me as well. Then the second thing, which is really important, the strategy is the key. So you definitely have to talk with strategists. So that's people who will use the output of the machine learning model in the future. And you have to know what they want to use, what they have already used, and what are their thoughts around it. And you should also tell them what are your models capable of, what you can do, what you cannot do, what is reasonable, what is not. So, and it allows us to go with this data-driven approach. So you first look at the data, you explore how ML and data look like, and then you tell the strategists like what you found out, and then together you try to think about what is the best way to go forward. Yeah, another aspect is validation. So basically how to know whether your model is good or not. So because all these metrics are quite technical, and sometimes in real life they are not matching with the results. And usually, like, you don't have anything better than running A/B tests. But again, you can configure them in a different way. But that's also a huge thing. And so these drift checks. So we have to be sure that we update our models regularly. So also that if something really serious is happening in the world, like COVID, we have to be sure that our data represents these events. So basically, we have to regularly monitor whether there are some drifts in the data, in the model outcomes, or in the targets, let's say. And yeah, the thing which is sometimes a pain, but I want it to be not a pain, but some pleasure, data quality. So first of all, if you have some data, please collect it. So it's very easy to collect the data. It's very hard to get the data or to restore the data which was not collected. So collect everything and keep the history. Do not overwrite the data, because yeah, collecting is not enough. If you collect the data but overwriting it every month, it's also of not great use. And data warehouse is essential. So in a project like this, where a lot of different experts are involved, so technical people, business stakeholders, software engineers, it's very nice to have some store or data warehouse where all the data resides, because otherwise, like, the The opposite example might be storing all the data in raw files, like CSV, for example. It could also be a way, but there are a lot of ways how to make things go wrong. And if there are these ways, then things will go wrong for sure. And just having a data warehouse will save you a lot of time and effort, and it will make your life easier. So just if your idea is to run ML tasks or ML projects not only once a year, I don't know, or make it like a part of your business, I think that creating a data warehouse is really essential before going deeper in this direction.
How do you keep the history of the data? So what do you collect in that term? So you write a document like these are the data from period going from to, or what else? What do you keep in your history?
Yeah, I mean, ideally, you could keep almost everything. Of course, I'm not talking like about terabytes and petabytes, but if you, for example, if you know that your debtor has has paid like 10 euros today and 11 euros tomorrow and 12 euros like in a week, it's nice to have all these 3 separate records in your database, not aggregating them into one. Because sometimes people think that it's more efficient, they aggregate this into one record, and then afterwards you don't know that there were 3 separate records. Sometimes we will even override the data, so meaning that, for example, the debt was 1,000 in January and it was 5,000 in March, and people say that, well, January was quite long time ago and we don't need this information anymore. So we just overwrite it with the March data, and we just lose this history. And for the future, if we want to apply ML needs a lot of data. So that's basically if your data changes somehow, it's nice to store the previous result as well as the next one. Of course, it's not if it's not petabytes.
And is the cloud storage function like a data lake?
Sorry, what about data lake?
Is the cloud storage function like a data lake?
Yeah, it could be. Yeah, I mean, it's basically the approach that you want to take. You could build a data lake, meaning that you can introduce a couple of layers like raw data, a bit preprocessed and nicely preprocessed. You could also do a warehouse, which is more like SQL oriented. It's up to you. I think it depends more on the possible users of this data. So if you have a lot of technical users in your company and they are capable of dealing with data lake themselves, then just keep it there. But if you have a lot of business analysts, so people who like running SQL queries or look into BI tools and graphs, I think it's nice to transform this data lake into a data warehouse, so to make it a bit more useful.
Igor, I have a small question.
Sure.
For big companies, so like a big banks, or I don't know, maybe virtual banks, or even some different financial institutes, I guess this is a very regular task they have to solve anyways, and probably they outsource it like in your project. But are there any things, any areas that you didn't cover, but very applicable for them in a big companies?
Yeah, it's like a very broad question. So yeah, of course, it makes sense to start. For me, it makes sense to start with from data quality. Yeah, and currently we're talking about it. And I'm pretty sure that every big bank is already investing a lot into data quality. I don't know. I think now is the time when all this digital transformation is happening, and there are a lot of organizations which were founded quite some long time ago, and they were living in the area of like before internet and in the early stages of internet. And now you mentioned these online banks. They are mostly founded quite some years ago, and they already were created as a technical organization. So meaning that they already care about data quality. They have all these data lakes and warehouses and I don't know, feature stores or whatnot. And for a bigger organization, I think it is very essential to I don't know, like not to be up to date, let's say, with current technologies. to see what the smaller companies are doing with their data and try to explore these directions. So also to care about the business customer, to organize warehouses nicely, to think about how the data might be used by data scientists or machine learning engineers in the future to allow them, I don't know, some handy tools. And yeah, basically think a bit from different perspective, that you're not a huge corporate which has tons of data, but that you're a flexible and agile organization which is able to deal with different technical tasks. Yeah, sounds very broad, but not sure.
Yeah, thanks.
Yeah.
Okay.
Yeah, so I think I have only one slide left. Some kind of a final wrap, or wrapping. I called it Foundation because I like this book, and recently there is a TV series on Netflix or HBO, I don't know. But whatever. So here is this pyramid, and we'll go from top to bottom. On the top, we have the models, and it's very nice to have the models which perform nicely and give the valuable outcomes, but they won't function without the proper data. So the high quality data, the prepared data, the clean data, and so on. But the data itself and the models will not be possible without the proper infrastructure. So if we don't have all these data warehouses, data lakes, if we don't run the pipelines in a nice manner, so all of this is infrastructure, we won't be able to get anything profitable and useful from data and models. But all of this will be useless without a nice strategy. So we have to understand what we're doing and why we're doing this. So before building a lot of data lakes and thinking of what models we can train, we should be sure that we know the goal, that we run the project nicely, and we understand what to do with the outputs of the model. And I think that all of this is much easier when you have cross-functional teams. So when in the same stand-up, you could discuss something between business analyst, strategist, software developer, data scientist, data engineer. Like, it's a very broad and comprehensive types of knowledge that they possess. And if they are in the same room or in the same project or in the same discussion, it will be very fruitful, and the right strategy might be born much quicker. And also all of these aspects will be less prone to any kind of errors or mistakes in the future if you have these cross-functional teams. So that's just my thought, that everything is coming, like, it's connected in some direction, and cross-functional teams rule. Cool, that's all of it. Thanks a lot for listening. Some contacts of X Technology. So now we have a website. Thanks a lot, Alex, for it. We have a really cool website. Yeah, and thanks a lot, Crane, so the company that I work on. And so basically that project is one of the projects that we run in Crane. And so feel free to follow us on Telegram and Twitter.
Yeah, I guess we're gonna have a small discussion room after, or retro session after, right after the event, in our Telegram channel. So if you wanna join and ask us some question directly, we gonna be there in 5 minutes, I guess.
Yeah, would be awesome to see you there. Please join. I like interactive processes.
Thanks,
Thank
Igor.
you, Igor, for a great presentation. This was very useful.
Thank you.
10 years of experience in one presentation.
10 years. Well, almost.
So
good.
Join us.
Yeah, let's take some beverages and meet in a group.
Yeah, so in 5 minutes, or what did you say? Sorry.
Yeah.
I dropped.
Yes.
Cool. Yeah, and for those who want to join us there, thanks a lot and have a nice weekend. See you.
Yes, enjoy your
next event.
Yeah. So,
yeah.
See you.
Bye-bye.
Bye-bye.
Bye.